Welcome to Enots Engineering, I'm Alan. In this week's video we continue making the mill tramming gauge. Tramming is the process of squaring the head of the mill spindle to the table. We squared up a mile steel bar and drilled two 10mm holes. The distance between the holes matched the length of the table from the centre to the edge of the table. So when you put a dial indicator in here and turn this in the mill, the indicator will travel from the front of the table to the back of the table. And today we're making the spindle and the bronze bush which holds the dial indicator. So let's go into the workshop and see how we do it. What I'm making at this moment is a brass insert to fit into the steel bar which we made on the milling machine to hold the dial indicator. So that's what we've got so far. This diameter needs to come down by about 2mm. The bore is 8mm, and that now will go onto the dial indicator. This piece on the end just misses the dial on the outside, so I can turn the dial. This shoulder here will fit onto the steel bar. This part is a valve stem for a valve in an engine, in a car engine. They were throwing some away and I thought it's useful material. It's probably bronze. So the next thing I want to do is hold that on a mandrel so I can turn the outside down. I've just held a piece of steel bar in the 3-jaw chuck. I'm turning a mandrel so I can hold the brass piece so I can turn the outside. So we've got 325, 27. So what I'm going to do now is I've got the compound slide and I've made it about 1/2 degree. Wind it in, touch the bar, lock the saddle. Now I'm going to cut a taper using the compound slide set at about 1/2 degree. bit on there now. I just want to tap that on. And just hope that there's enough force on there to hold it in position while I turn the outside. So the outside needs to be 10mm to match the size of the hole that I drilled in the bar. This is 0.471, 10mm is 0.39, so I've got quite a bit of material to come off this yet. So what I'll do now is mark off the length. See if I can go into there and cut that length. 10mm 0.397. The moment this is 400, so I'm going to leave it at that, and I think now what I'll do is part the bar off. Put a chamfer on. There's 1, 2, 3 thou. So that will just go in there. So that's finished on there. Just sticks out the bottom a bit. The next thing I have to do is put a slot into this, cut a slot with a hacksaw so it'll spring in and out when I tighten the grub screw up. It is. That slot is on the side here going across, so when this is screwed in at the end it'll crush the bar. And now I'm just taking the reamer they used at the start just to ream out the bush now it's been assembled onto the bar. That dial indicator fits in there, and the screw will lock that into position. Okay, so what we've done, we've taken square steel bar, I've milled this all the way around just to give it a better finish than it did have. We've drilled a 10mm hole here and a 10mm hole 15mm in, straight through the bar. In this hole we've made a brass bush which supports the dial indicator, and on the other side it sticks out just so that it stops the dial indicator going too low in the bar, so you can still turn the bezel without it rubbing on the edge of the bar. We've put the split down the bush, so when you just need to nip this cap head up and it'll grip the dial indicator. So the next part of the project, we need to put into this hole a bar so we can hold the hold unit in the milling machine spindle. 12mm bar that goes down to 10mm to press into here, and then on the underneath I'll just drill a hole in the bar and put a cap head and a washer to tighten it up just in case it comes out. So I'll take this bar out now I've finished with the mandrel part, and I'll use the other end of the bar to make the spindle traverse on. Check the diameter. .565. So what I want to do is turn that diameter down to 12mm, which is 472, and that will hold in my collet, and then I'll turn the end part down to 10mm to hold in the bar. centre drilled that end, and that's because I want to use the centre to steady it. It's about a thou bigger here than it is down here, so I want to use the centre to stop it flexing and put the final cut on to get this down to 12mm. Now I've finished the two diameters. One diameter is 12mm to fit an ER20 collet, and the other diameter is just over 10mm to be a press fit into the bar. Take my tool post out the way. There's some oil on. So that should fit in there, 6mm thread. I'll take about 1mm off there because I don't want the bar to come out of the hole. I want it below the surface of this face. I'll come in 1mm. I've changed the tool just to put the chamfer on the end. And all that remains for this is to part the part off. Now I've just put the part in the chuck, lightly held it, and all I want to do is face it off and chamfer the corner. There's the bar. That should go into there, and all I need to do is press that in. Put this in the vise. I've got a jaw protector on this side to stop damaging the bar, and some angle on this side. Just tighten the vise up. You'll see here it's below the surface. You'll see there on the back I've just put a button screw with a spring washer, so that just puts some pressure on there. It probably doesn't need that because it's pressed into the bar, but I've already drilled the hole and tapped it, so it's ready for it. That's the finished mill tramming gauge. Now if you want to make one of these and you want to measure from front to back and from left to right, ensure that this distance is from the centre of the table to the edge of the table at the front or back. Well, that's it for today. We'll use the gauge next week to check how accurate the mill is set. So thanks for watching. We'll see you next time on Enots Engineering.